Hello everyone. So in today's problem, we are now faced on another question about the couple, force couple system. Again, this time we are being asked to determine the resultant of three forces and a couple using a force couple system located at point A. So this question asks us to find the resultant of the three forces and relocate these three to point A right here. So, and we notice that aside from the forces, we are equipped with one moment. So when you see the moment like this here, that is, we call it a couple moment. A couple moment or a free couple moment is the moment that apply onto a certain system, which means the location of the moment does not really important because it will apply this moment to the entire specimen. Okay, so we can easily move this couple moment to point A without having to transverse or multiply by anything, just move it there to here. Okay, so but now we know that the hard part of this question is to find the moment that generate by these three forces. Okay, when we translate those forces into point A. Okay, so we are dealing with multiple forces. I will name each one as F1 here, F2, and then F3 here. Okay, so now I would like to distribute the F3 like this one. So we know that F3 is inclined force. So that means if we distribute the force, it looks something like this one. So if we have on the left side will be 5 kilonewton time cos 20 here, cos 20, and this one will be 5 kilonewton time sine 20 degrees like this. Okay, now that we distribute the force number 3, so that means the original force will be eliminated. So looking back on original force 5 kilonewton. So to avoid any further confusion, I will remove this one, this force. Okay, so now we are seeing the force in two directions, the vertical direction and horizontal direction. Okay, so if we want to determine the resultant of three forces, first we have to take into account of the summation of the forces. Okay, so before we take a summation, we try to translate the force one by one. So I translate F1 here into point A. To do that with the similar concept that we have learned, we move the force there to here in the same magnitude. Then we added the moment that would have been generated by the force that was previously on its previous location. For example, we are interested in point A, right? So this force generates the moment in counterclockwise direction. Okay, so when we move the force from here to here, the moment should come with it also. Okay, so the moment that generated by F1, I will call it M1. Okay, so M1 equal to F1 time 3.5 meter. Okay, so now M1 equal to 3 kilonewton time 3.5 meter, and that will give us around 10.5 kilonewton time meter. Okay, then once we obtain the moment by F1, we remove the original force from its own location. To avoid any further confusion, okay, here and there. Okay, now this is F1 in the new location. Okay, so next we do the same thing with F2. So F2, you move from there to here in the same direction, same magnitude. Okay, then the moment that would have generated by F2 around point A will be clockwise direction. So which means M2 here will equal to F2 times 2 meter, but it will equip with minus sign, because like I said on previous video, we will from now on we will assume that the counterclockwise is in positive direction, positive sign. So M2 equal to minus 4 kilonewton times 2 meter, which should give us minus 8 kilonewton times meter. Okay, then we again remove the F2 from the system because we already translate that force onto point A. Okay. Then now we look at the F3 in both directions. So F3, if F3 with the force in horizontal line, it would not generate any moment. Okay, so that means that the M3 by horizontal axis, x-axis, will equal to 0, right? Because the line of action of the force passing to the rotation point. Okay, you may ask, what if I distribute the force to be maybe this side and this side, for example? Okay, I say you could do that, but if you do that, that means the force here will generate a moment, and it giving you more work because now you have to calculate the moment that would generate by this perpendicular distance. Okay, because we know that the force applied in this line of action, right? So in this line of action, we could distribute the force at any point in the line. We could put here, or we can distribute here and here. The point is to find the point, the best point to distribute it, to giving it an easier way to calculate those distributed forces. Okay, I select this point because it's more convenient, because it passes to the point A. Okay, so moving on. So now we can move the force, the F3 in horizontal axis easily to point A without having to calculate any moment. Okay, we call it 5 kilonewton times cos 20. Okay, and now we eliminate the force here. Okay, now we left with the last one, which is F3 in y-axis. F3 in y-axis. Okay, so in F3 in y-axis, yes, we can move it to point A just like F1, and we have to calculate the moment that would have generated around point A. Okay, so let's look at let's look at the M3 at y-axis. So how does this force generate a moment? So if the force is in this direction, it has perpendicular distance here around 1.5 plus 3.5, which is 5 millimeter. Okay, so we multiply the force of 5 kilonewton times sine 20 times 5 meter. Okay, so now the moment is in counterclockwise direction, so I didn't put any minus sign in front of it. So now m3 in y-axis will give us 8.55 kilonewton time meter. Okay, now when we calculate the moment, that means we could move the force now into point A, but the force will act as this direction of the magnitude of 5k newton times sine 20. And now since we have that, we can remove the force that was previously equipped here. Okay, so now we have the moment of first m1, then m2, which is minus sine, and then m3, which is again positive. Okay, so with this information, we could summarize the forces and moments into a force couple, only a force couple system. Okay, so the easier one would be the summation of the force sigma fx, the total summation of the force in x direction, which is only minus 5 kilonewton times cos 20. Okay, minus sign here because I assume that this direction is positive. Okay, so the only horizontal force acting in this system is this one, which is act toward minus sign. Okay, that's why I put minus in front of it. Okay, then with that in mind, sigma fx will equal to minus 4.7 kilonewton. Okay, now sigma fy, we have three forces. Okay, so we assume that upper direction is positive. That means we have 4 kilonewton, yes, positive 1, minus 3 kilonewton downward, and minus again 5 kilonewton times sine 20. The summation gives us 0.71 kilonewton as the sigma fy. Okay, now the last one, summation of the moment sigma m in at point A. So we have how many moments here? M1, M2, M3. Okay, but don't forget that we also have the free couple moment here. So that will be the last one, M4. Okay, in our summation. Okay, m sigma m a equal to m1 plus m2 plus m3 plus m4. Okay, and then the sheet should give us 10.5 minus 8 minus 8.5, oh sorry, plus 8.5 and plus 10, which is the free couple moment. Free couple moment. Okay, now sigma ma will give us equal to 21.05 kilonewton time meter. Okay, now so the last part is since we know that sigma fy is in minus, sigma fx is in minus, so that means if we remove all the forces or the moment into one force and one moment, it should give us the total summation of sigma fx and y in the vector manner. So minus fx is this direction, right? Minus fy is this direction. So that means the moment, the force, the resultant force will act in this direction. Okay, Fr. Now it's our job to determine the magnitude of how much is Fr. Okay, so Fr is easily determined by the square root of the minus 4.7 square plus minus 0.71 square. Okay, so that is the magnitude of Fr. Okay, now the resultant moment is in positive side, right? So this should give us here mr equal to 21.05 kilonewton per meter. Okay, now that is the end of this question. Okay. So I hope you learned how to solve this question by my solution step by step. And to briefly explain what I did here is that I moved the force from its original location to the point that the question wants. Then after that I calculate those moments from the force translation. Then I I make a summation of the force in x direction and also in y direction. After that I make a summation of the moment of M1, M2, M3 and the free couple moment M4. Okay, then after that I summarize the system to be equipped only one force and one moment. Okay, and now to make it more clearly, this free couple system should be removed from the figure because make we already make summation of that. Okay, so it would be look something like this in the end. Okay, I hope you enjoy this video and the step by step guideline, and we'll see you in the next mechanic problem. Thank you for watching.